National Electrical Code Article 250.122 addresses the sizing of equipment grounding conductors. Specifically, Section B, equipment grounding conductor larger than circuit conductors, states that where the equipment grounding conductor is larger than the circuit conductors, its size shall not be reduced at any point in the system. This means if you've initially chosen a larger grounding conductor, you must maintain that size throughout the entire run. Section C, equipment grounding conductors smaller than circuit conductors, is where you'll find guidance when the equipment grounding conductor is smaller than the circuit conductors. In this case, its size must be in accordance with Table 250.122 of the National Electrical Code. Table 250.122 provides minimum sizes for equipment grounding conductors based on the rating or setting of the overcurrent protective device in the circuit head of the equipment. To use Table 250.122, you first need to identify the rating of the overcurrent protection device protecting the circuit. This is typically a circuit breaker or fuse. Then, locate the corresponding row in the table that matches the overcurrent protection rating. The table will then specify the minimum size of the equipment grounding conductor required based on the material of the conductor, either copper or aluminum. It's important to note that the table provides minimum sizes. You are always permitted to use a larger equipment grounding conductor than what is specified in the table. Factors that might influence the selection of a larger grounding conductor include concerns about voltage drop, future load increases, or simply a desire for a more robust grounding system. Section D of Article 250.122 covers parallel conductors. It states that where equipment grounding conductors are installed in parallel, their combined cross-sectional area shall not be less than the required size for a single conductor. This means if we are using multiple equipment grounding conductors in parallel, the sum of their ampacities must be at least equal to the ampacity of the single equipment grounding conductor that would be required based on Table 250.122. In this specific scenario of installing 4 200 amp meter packs with 10 amp breakers at 120/240 volts, and the load center being more than 6 feet from the service panel, requiring separate neutral and grounding bus bars and 4 feeder conductors, using 3/0 copper conductors with a 90 degrees Celsius rating and 225 amp ampacity for the ungrounded and grounded conductors, the equipment grounding conductor size needs to be determined based on the 200 amp overcurrent protection for each meter pack. Consulting Table 250.122 for a 200 amp overcurrent device, the minimum size copper equipment grounding conductor would be number 6 American wire gauge. This is the minimum size permitted by the National Electrical Code. You could choose to use a larger size, such as number 4 or number 3 American wire gauge, but you cannot use a smaller size. Since you are running parallel conductors for each meter pack due to the distance, you need to ensure that each parallel equipment grounding conductor is sized such that their combined ampacity meets or exceeds the requirement of number 6 American wire gauge copper. If you were to run 2 parallel equipment grounding conductors, for example, each would need to be at least number 8 American wire gauge copper, as 2 number 8 American wire gauge conductors have a combined cross-sectional area approximately equivalent to a single number 6 American wire gauge conductor. Keep in mind that these are minimum requirements, and local regulations may impose stricter requirements. Always check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Proper sizing and installation of equipment grounding conductors are crucial for ensuring the safety and reliability of the electrical system. An inadequately sized grounding conductor can lead to increased touch voltage during fault conditions, posing a shock hazard. It's also important to ensure that all grounding connections are properly made and are mechanically and electrically sound. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Remember that the National Electrical Code is updated regularly, so it's important to consult the latest edition for the most current requirement. Also, always refer to the manufacturer's instructions for specific equipment grounding requirements. When dealing with electrical installations, always prioritize safety. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Electrical work can be dangerous and mistakes can have serious consequences. Always energize circuits before working on them and use appropriate personal protective equipment, such as insulated gloves and safety glasses. In addition to equipment grounding conductors, there are other types of grounding conductors used in electrical systems, such as grounding electrode conductors and bonding jumpers. Grounding electrode conductors connect the electrical system to a grounding electrode, such as a ground rod or water pipe. Bonding jumpers are used to connect different metallic parts of the electrical system together to create a low impedance path for fault current. All of these grounding conductors play an important role in ensuring the safety and reliability of the electrical system. When sizing grounding conductors, it's important to consider the entire electrical system and all of the different types of grounding conductors involved. Make sure to consult the National Electrical Code and any applicable local regulations to ensure that all grounding conductors are properly sized and installed. Remember that proper grounding is essential for protecting people and equipment from electrical shock and fire hazards. Take the time to understand the requirements for grounding conductors and ensure that they are properly implemented in your electrical system. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific guidance on your electrical installation. Also remember to consider the environmental factors that may affect the sizing of grounding conductors. For example, in corrosive environments, it may be necessary to use larger grounding conductors or corrosion-resistant materials. In areas with high soil resistivity, it may be necessary to install multiple grounding electrodes to achieve an adequate ground resistance. These factors should be taken into account when designing and installing the grounding system. Proper grounding is not just a matter of meeting code requirements. It's a matter of protecting people and property from the dangers of electricity. By taking the time to understand the principles of grounding and following the applicable codes and regulations, you can help ensure the safety and reliability of your electrical system. In summary, when sizing equipment grounding conductors, remember to consult National Electrical Code Article 250.122 and Table 250.122. Consider the overcurrent protection rating, the material of the conductor, and whether parallel conductors are being used. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Make sure that the equipment grounding conductors are properly connected to the grounding bus bars and that all connections are tight and secure. Regularly inspect the grounding system to ensure that it is in good condition and that all connections are still tight. If you find any loose or corroded connections, repair them immediately. Remember that a properly installed and maintained grounding system is essential for protecting people and equipment from electrical hazards.